talking about areas under a curve in this case. And what we want to do is we want to calculate the area between f of x, which is equal to x squared, and the x-axis. And before we can actually figure out a way to calculate this exactly, which we can do, we're first going to estimate this. So we're going to estimate the area under f of x equals x squared. And by doing so, we're going to have to do a lot of adding, believe it or not. Now, there's a method to how we go about doing this. First thing we're going to do is we're going to divide the interval into parts. Now the interval is going to be, it's going to start here at A, and it's going to go here to B. And we have to decide how many subdivisions that we want. So I'm going to say n is equal to the number of subdivisions. Between A and B. So we basically, what we want to do is we want to cut it up into smaller pieces. We want to say how many pieces we're going to cut it up into, and then we are going to estimate those areas. Now, let's put a 1, a 2, and a 3. And so we have these points right here. Now, what would be, when x is 4, what's this point up here? 16. And then when x is 3, this is 9, and this is 4, and that's 1. So I can put a 16, 9, 4, and 1. Now, the way that you do your subdivision when you're going through here, this is like my f of x there, is always going to be b minus a over n. So basically what it's going to do is it's going to say, well, how big is the interval? And then we're going to cut it up into n parts. So in this case, it'd be 4 minus 0. And let's say I want n to be equal to 4. So I'm just going to cut this into 4 parts. So what's 4 over 4 in this case? 1. This tells me that each subdivision is 1 unit in length. Now here's where it gets kind of tricky. There he goes. Got to keep up that all-state persona. Now we can estimate this. So I'll go step 2 over here. By using a left endpoint, right endpoint, or using the midpoint of each interval, or not interval, each subdivision. And what I mean by it is use the point to create a rectangle. So what we're going to do is I'm going to use, for this example, we've divided it up, our interval's 1, and I'm going to use a right endpoint, which basically says I want to use the rightmost endpoint of the interval to create my rectangle. So here's what the rectangle would look like. Now, with the right endpoint, which one is it? Is it A or is it B? B. Alright, so this is my right endpoint. And I'll just go over here and say left. Now, to create the rectangle I would do this. I would use this. That's my right endpoint. Let me see if I can make it a little bit clearer. That's going to create this rectangle right here. Now I'm going to use this right endpoint for the second one and create this. Then I'm going to use this one, and then I'm going to use this one. So that's my estimation. I'm going to create rectangles. Now, how many rectangles are there? Okay. So, are we okay with this right now? Alright, so we have I'll do this. Magic. I have more space to work. So we have 4 rectangles. Find the area of all 4 rectangles. So what's the area of a rectangle? Yeah, it's length times width. So let's say this first one. What's the length of rectangle number 1? The length is 1. What's the height? 1. So that's equal to 1. What's the second rectangle? What's the length? Goes from 1 to 2, which is 1. The height is 4, so this is going to be a 4. Now the third rectangle, what's the width? 1. That's a 9. And the fourth rectangle in this case, what's the width? And then 16 is the height, so that's 16. So if I'm going to this is why we do the summation. Add them up. 1 plus 4 plus 9 plus 16. Which is what? 25, 26, 30? So 30 units squared. Now, that's an estimation using the right endpoints. Yes, sir. n. It's just how many rectangles that we cut this. Yeah, n could equal 4, n could equal 10, n could equal 50 if we wanted it to be. Now, let's try to do, well, let me ask you this. Is this the area? Is it more or is it less than the actual area?
Probably less. No, it's less. Because we're adding like stuff on the rectangle.
Well, look, there's that chunk, that chunk, that chunk, and that chunk. We're trying to compare it to the area that's under the curve. All that red stuff is extra, isn't it?
Yeah.
Yeah, so this is 30 is more than. So 30 is going to be greater than the actual area. Now, let's try to do a left endpoint estimation. So we did a right endpoint. Now, let's kind of move this up, move those out of the way. Now, if I did a left endpoint, I'll redraw it because it'll be a whole lot easier if we redraw it. And is it okay if I just draw that part of it? Can I cover up this part? Alright, we can always go back and look at it again. Alright, so that's 4. And I know that's 16. 1, 2, 3. 1, 2, 3. And the points here, that's a 1. I know that's 4. That's 9. And up here is 16. Now, if we do left endpoint, it wouldn't be flipped. We're still going from 0 to 4. No, we don't do that. We'll do that later. Not negative. It's not going to be negative. We're still looking for the area underneath the curve, but in one little interval right here. From here to here, which one's the left? 0's the left. So I'm going to use that one to draw my rectangle. And there's that rectangle. Now from 1 to 2, which one's the left? 1. So I'll use 1, I'll move up, and then I'll draw the rectangle like that. And I'll use this rectangle. Now from 2 to 3, what rectangle are we going to use? Or what endpoint? 2. So I'll come up with this. And then from 3 to 4, since we're still doing left endpoints, which one am I going to use? 3 or the 4? Which one am I going to use? 3. So I have 4 rectangles again. There's rectangle 1, there's rectangle 2, rectangle 3, rectangle 4. So R1, what's the width? 1. What's the height? 0. So that area is 0. R2, what's the width? What's the height? 1. R3, what's the width? What's the height? 4. And R4, what's the width? And what's the height? So I get a 9. So if I add up these, 0 plus 1 plus 4 plus 9, that's 14. Now, my actual area, now, let me ask you this. Is this bigger or smaller than the actual area? Yeah, it's a lot smaller. It's leaving out this chunk, this chunk, this chunk, and this chunk. So the actual area is between what? 14 and 30. There's a third way to do this. Do the midpoint. But first off, does that make sense how we came up with our left point and came up with all the rectangles? Yeah.
Wouldn't the 14, 30 minus 14 equal the actual area?
No. Well, maybe.
It'd be a lot closer.
That's a good question. Research it for me. Well, I don't know if it is. Let's do midpoints now. All right. Now we know that we cut it up into 4. Now, what's the midpoint between 0 and 1? 0.5. Now, if I create the rectangle, I'm going to create the rectangle here. Now, let's just figure out the area for the first rectangle right off the bat. What's the width? What's the width from here to here? 1. Now, I need to know what this value is. It's not 0.5. It's 0.5 squared. Because remember, this is f of x, which is equal to x squared. Now, 5 times 5 is 25. So this would be 0.25. Now, what's the midpoint here? 1.5. So I'm going to go up and I'm going to use this rectangle. So rectangle 2, what's the width of the rectangle? And this would be 1.5 quantity squared. .25. Now what's the midpoint between 2 and 3? 2.5. So I'm going to create the rectangle that goes through here at 2.5. The area of that rectangle is, again, 1 times, now it's 2.5 quantity squared. That's a 6.25. Now what's the midpoint between 3 and 4? 3.5. So I'm going to go up to here. And now the area for the fourth rectangle, 1 times 3.5 quantity squared. That's 12.25. Add these up. 0.25 plus 2.25 plus 6.25 plus 12.25. We get 21. So we got 21 units squared. Doesn't look like it. Yeah, the midpoint is closer than the other ones because it has a little bit that it's above, and it has a little bit that it's missing out on. So there's a little bit above and a little bit that it's missing out on. A little bit above, a little bit that's missing out on. Above and it's missing out on. So these don't exactly cancel each other out. And this isn't the accurate. This is not the exact area. But it's a lot better of an estimation. Now, the method that we're kind of using here, when we figured out, we used right endpoints, we used midpoints, we used left endpoints. And I know this isn't going to do it justice in 7 minutes, but how do you think we'd get closer and closer and closer to an actual area?
You keep breaking it down.
Just thinking about areas. Just think about the areas of the rectangles. What do you mean by breaking it down?
You take 0.5 and then you take half of that, and you take half of that again. You divide, you break it down to more subdivisions.
All right, so you're saying more subdivisions, more rectangles.
Yeah, more
How many more rectangles?
infinite number.
You're absolutely 100% correct. We want an infinite number of rectangles, and you guys jumped on that pretty fast. If we make this rectangle infinitely small, you get something that looks like this, which is just a segment, right? It has an infinitely small width. And then we just keep on cutting it and cutting it and cutting it and cutting and cutting and cutting and cutting. Now, this is what the rectangle will actually start to look like. If we were able to use the microscope and look at, for dramatic purposes, I'll actually zoom in on. I have enough. Alright, here's your rectangle. We zoomed in on that segment. So here's our rectangle, zoomed in on it. This part, it would be a delta x. Actually, now I gotta zoom out on it because I zoomed in too far. What would be the height of this rectangle?
Delta Y.
No. F of x. Well, think about what we used with the regular rectangle. These guys over here. I used this guy, which was f of 0.5 for my height of that rectangle. I used f of 1.5, f of 2.5, and that last one was f of 3.5. To figure out the heights of these rectangles, we're going to have to use this. And now, what would be the area of this rectangle? F of x times delta x. And how are we going to figure out the area? Add them all up, right? So we're actually going to do this. From 1 to infinity, f of x sub I times delta x. And this is where I'm going to stop right now, because this is taking us right up close to what we're going to learn and why we're going to learn it. So for right now, here's what you're going to do.